Okay, in this session we're going to talk about units, dimensions, and proportions. Some of these things will be familiar to you. I think the broader concepts will be familiar to you, but some of the terms might be new. Okay, let's start off talking about dimensions and what we mean by that. So a dimension is the name that we give for a particular feature, particular concept of something. So if we talk about length of this sheet of paper, for instance, would be the dimension. A dimension length, and we might give it units of millimeters or centimeters or inches. Dimension could be mass, and that's something we measure in pounds, stones, or more usually grams and kilograms, more usefully. Another dimension is time. Time being measured in seconds, hours, days, weeks, months, years, decades, etc., etc. And we give these dimensions standard symbols. So length we call with L, dimension length, dimension mass, M, dimension time, T. There are other dimensions as well, but we'll just concentrate on these. So then we can use this information and think about the dimensionality of the volume of something, or the area of something, or speed. So let's think. So volume is a length times a length times a length. So volume has dimensions length cubed. Velocity, that is given by a length, distance, divided by time. So that has dimensions L divided by T, or L to the T to the minus 1. Acceleration, that is velocity divided by time. So Lt to the minus 1 divided by T, which is the same as Lt to the minus 2. Okay, so the dimensions of volume are L cubed. The dimensions of velocity are L to the T minus 1. Acceleration L to the T minus 2. We can go a bit further. Think about some of the concepts that you might remember from high school physics. So force is mass times acceleration, Newton's second law. So mass, dimensions is m, acceleration we have up here is L to the T minus 2. Work, or energy, is a force times a distance. Okay, so force is mLt to the minus 2. Distance has dimensions, L has dimensions length, so we combine that to be mL squared t to the minus 2. So the dimensions of energy are mass, length squared, time to the minus 2. One more, we can talk about pressure. Pressure is force divided by area. So force is mL t to the minus 2. Area is length times length, or length squared. So we can simplify this. mL divided by L squared gives us mL to minus 1. Okay, I'll let you work that out for yourself. But the dimensions of pressure are then mass per length time to the minus 2. Okay, so far so good. But let's think about units. And units, as I said, are something that we use to quantify dimensions. So if we take our examples again of force, so force, I said, has dimensions of mL t to the minus 2. And if we do this in standard units, SI units as we call them, we can give units to each of these dimensions. So mass is in kilograms, length is in meters, and time is in seconds. So the units of force are actually kilograms, meters per second squared. And actually, we call that a newton. So you hear something about a force being 10 newtons, so that's actually force of 10 kilograms, meters per second squared. Similarly with work, or energy, that has, sorry about my writing, energy that has dimensions of mL squared t to the minus 2. Let's insert some units in here. Kilograms, meters squared per second squared. That is what we call a joule, which is also the same as a Newton meter. Okay, because it's Newton times meters, and we call that a joule. And pressure was our other example. Remember, this was force divided by area, and that had dimensions of m, L to the minus 1, T to the minus 2. And that, if we insert our standard units in, is kilograms per meter per second squared, or kilograms meters to the minus 1, seconds to the minus 2. And that is a Pascal. Okay, so atmospheric pressure, if we're reporting it in standard units, is in pascals, but that relates back to these basic units of mass, length, and time. Okay, so that's how we work with dimensions and units, and we use this a lot in things like physics and in earth science to help us kind of understand a bit about a quantity that we're measuring. So let's just take some simple example here, and just to drive home something. So what we do to the units, or what we do to the numbers, we also do to the units. So we think of speed. Give it a simple example. So speed is distance divided by time, speed or velocity. Now let's give it some numbers. Let's say it's 60 miles, and we went that in 2 hours. Okay, now we would work out the speed would be 60 divided by 2, which is 30, and then we do the same to the units. Miles divided by hours, so 30 miles per hour. Or we could write that equivalently as 30 miles hour to the minus 1. H, or HR, is often the abbreviation we use for hour. Okay, let's think about something about how we convert between units. Moving on to a slightly different topic here, but it's still all about manipulating units in the same way that we do with numbers in an equation. So let's start off. We've got 6.2 feet per day. So that would be a speed, right? Distance divided by time, L over T, where L is in feet and T is days. I want to convert that into something more sensible, meters per second. Okay, so we need to convert feet into meters and days into seconds. So to do that, we need to use a conversion factor. So there are 3.28 feet, we'll abbreviate that FT, per meter. And the number of seconds in a day, well, you can work that out. That's 60 times 60 seconds in an hour times 24, which equals 86,400 seconds in a day. Okay, how are we going to use these conversion factors to convert this into meters per second? So we need to think about how we're going to write these conversion factors out. So let's just do it like this: 6 feet per day. Now let's think about converting the feet to meters. Now if we just multiplied that by 3.28, that would then give us 2 feet on the top. So that would then become feet squared day meters, which makes no sense to us. So we know that we want the feet to cancel out. So the feet needs to be on the bottom of this conversion factor. So therefore we need to flip everything up the other way. So this then becomes 1 over 3.28 meters per feet. Okay, because now we know that when we multiply, the units will cancel out, the feet will cancel out. Now if we were just to multiply this straight through, we'd be left up with 6.28 divided by 3.28, that'd be meters per day. Okay, we're going to do our other conversion at the same time as well, just to multiply straight through. So now we want to go from days to seconds, and here we've got seconds per day. Similarly, if I just wrote down here 86,400 seconds per day, that would give us days squared, because the days would be both in the denominator. So we know we need to flip that over 2, so that becomes 1 over 86,400 days per second. And we think this makes sense, right? There's actually 1 over 80, 1/86,400th day per second. That's the length, that's the amount of day there is in a second, basically. Okay, so we can see this now. If we just look through just at the units, in fact, let's write that out. We've got 6.2 times 1 over 3.28 times 1 over 86,400. Then we've got feet per day, meters per feet, days per second. The days cancel out, the feet cancel out, so we're left with meters per second. Then all that's needed to do here is do this sum. So 6.2 divided by 3.28 times 86,400, whichever way you want to do that. So just to be clear, 3.28 times 86,400 meters per second. And if you were to put that into your calculator, you would get 2.2 times 10 to the minus 5 meters per second. Okay, you can also write that equivalently as meters per second or meters per second. Okay, that's a unit conversion. You're going to get plenty more practice of that. Finally, I just want to talk a bit about proportion and ratios. So you'll be used to the idea of a percentage, 1%. And 1% we can think of as a fraction is 1 over 100. Okay, it's a proportion. It's like one part in 100. We can also talk about other ways of expressing proportion, not as just being part of 100. We can talk about parts per 1,000. So how would we convert 1% into parts per 1,000? So we can think of this as playing with fractions, really. So if we're going to convert to part per 1,000, we just need to find the equivalent fraction, which is 1 over 100. What is that over 1,000? Now with fractions, whatever you do to the bottom, you have to do to the top in order to make it the same. So here, that's 100, and we're multiplying that by 10. So therefore, we have to multiply the top by 10, the numerator. So 1 part per 100, 1% is the same as 10 parts per 1,000. So 1% equals 10 parts per 1,000. We can also talk about part per million, part per billion, part per trillion even. Let's just do a quick example of that. So if we've got 0.001%, what is that in parts per million, ppm? Okay, we work this out in a similar way as we did above. 0.001 divided by 100, so that's 0.001, that's its as a percent, and we want to know what that is in parts per million. So a million has 6 zeros, so 100, we have to multiply 100 by 10 to the 4 to get to a million, which is 10 to the 6. Okay, so 10 squared times 10 to the 4, remember our powers, 2 plus 4 equals 6. So we'll multiply it by 10,000. So therefore we have to do the same to the top, times 10 to the 4. So if we multiply this by 10, by another 10, by another 10, by another 10, basically we're left up with 10. So 0.001% is the same as 10 parts per million. Okay, plenty to practice on the worksheets, and we will talk about it more in the workshop sessions.